Hello guys, welcome to FMCG. I am your AIML consultant Shaunak here. So in this notebook we'll be focusing on data visualization library using Python by the name of Matplotlib. So Matplotlib provides good granular control over the graphs you plot, and it is quite popular in the field of data science. And the link, I have pasted the link over here in this notebook, where you can go and visit the official documentation and tutorials for Matplotlib. In this notebook we will be focusing on 8 plots and the graphs, namely bar plot, if you see over here how it is appearing, then histogram, basically it tells about the frequency distribution of the values contained in your list of values. Then we'll be focusing on scatter plot appearing like this, then bar chart on polar axis appearing like this, then line plot, pie chart is quite popular, you already must be knowing what is a pie chart, then stacked plot. In Matplotlib they call it stack plot, but it is quite similar to area plot. Then box plot basically tells the median, then IQR, that is interquartile range, and if you have any outliers it will show the outliers as well. So let's jump right into it. So first I'll be executing this code cell import warnings, and then warnings.filter warnings ignore, because some actions might be deprecated and it might throw some warnings to it. So since this is a demonstration notebook, we'll not be interested in any warnings, so it will just come in between the demonstration, so I'll ignore the warnings. Import libraries. So the libraries that I'll be importing will be Matplotlib. From Matplotlib I'll be importing pyplot, and from pyplot I'll be also importing cm is basically color map. So we'll be making use of this color map, where we'll be needing sequential color representation. I'll show you that when that particular graph arises. And sklearn datasets, load iris, I don't think we'll be needing this, so I have commented it out. And we'll also be importing numpy and pandas. Numpy for numeric calculations if and when it is needed, and pandas to read the data frame. So the data frame that we will be using will be of FIFA 22 players. So this particular data set is available on GitHub. So even if you search on GitHub you will get it right away, but for in the notebook that I'll be keeping on GitHub, I'll make sure to paste the link of this particular dataset, and also I'll be keeping the dataset itself, that is the .csv file. So don't worry about it if you want to practice yourself. And FIFA 22 dataset is it has almost 19,000 rows, more than 19,000 rows, and it has 110 columns. But we'll be not be focusing on all the 19,000 rows. Instead of that, we'll make a subset of only those players who are playing or registered for Manchester United. So if the club name is Manchester United, we will consider only those players. And if you want to check the shape of our filtered data set, it consists of 33 rows and 110 columns. If you want to see the list of columns, it is visible over here. So these are all the names of the columns: short name, long name, player positions, overall potential, value in euros, wage in euros, age, date of birth, height. The list goes on and on. If you are a FIFA buff, you can refer to this. And here I have created a helper function, wherein I'll be creating an array which will represent the sequential color. So this cm which we have imported over here, we have used it over here to create this color helper function. So it is cm.rainbow. So you don't have to necessarily use rainbow, you can use any other sequence, but for this particular example I have used rainbow, and here I have given it range np.linspace. So it will create an array of float between 0 to 1, and it will create the length of this array will be equal to the number you enter over here. So for example, if I want to show you a quick demonstration, let's say if you want to create an array of 10, so if you see it is creating this. If you want to check the shape, it has 10 rows and 4 columns. Now moving on, the first plot, it will be the bar plot. So for all the plots that I have included in this particular notebook, I have mentioned the format over here. So all the plots in Matplotlib, they follow a similar structure. So plt.figure fixed size equal to width and height. So this particular, so this should be at the beginning of your code block, because this will tell the system that you have to plot a graph whose height and width should be as per the integers you mention over here. So in our code block, while executing the code block, I'll explain it to you. Then plt.bar, so in bar plot you have to write plt.bar, bar means bar plot, and in that the parameters that will be passing will be x, which will be a nominal column, it will be along the x-axis, and the height of the bars will be the numeric column relating to the values in the nominal column. And then the color will be, if you want to keep it monotonous, you don't have to give this color attribute. If you want the bar colors to change as per the nominal value, then you can provide this array of colors. plt.title will give you the title of that particular graph. plt.xlabel will give you, will name your x-axis. plt.xticks rotation, so that will give a tilt to the nominal values on your x-axis. So by default all the values on your x-axis will appear horizontally. If you give rotation to it, it will give it a particular tilt to those particular names. Then plt.ylabel will give you the name to your y-axis. plt.legend, let's say if you have different color schemes in your graph, then plt.legend will show those particular color schemes and the value or property related to that particular color. And plt.show is used to show your graph. So for this particular example, I have created this particular dataset. So it is basically how much players, means let's say out of 33 players, 13 are from England, 3 are from Portugal, 3 are from France, 2 are from Spain, and so on. So keys are basically the nominal values, England, Portugal, France, and values are numeric values. So let us plot the graph. So plt.figure, and here fixed size, let's say we will give width as 10 and height as 6, and then plt.bar. So here on x-axis it will be country count dot keys. So keys we will get England, Portugal, France, and on y-axis is basically height. So height we will give as country count dot values. And if you want to give color, so we will make use of this particular helper function to give color. Color equal to get color list, and here we'll pass in the count of this particular dictionary, country count, and then let us give title to our graph, which will be plt.title, let's say players per country, and on plt.xlabel, that is naming our x-axis, in string will pass in as country, and plt.xticks, Here we will pass in the rotation as 60 degrees. Plt dot y label, here we will give the name as count, and finally plt dot legend, and then plt dot show. So this will show our graph, and if I execute it, module x, okay, so I made a typo over here. It is xy, LABL. Yeah, so now it is appearing, and if I just increase, let's say if we increase it to 15, and let me reduce this to 4. So legend is not applicable, so that's why it is giving this warning. So I'll just remove the label, and if you see, we are getting a graph, players per country as the title, x-axis, x label is country, y label is count, and we are getting a good colorful graph as per the rainbow. So 13 from England, 3 from Portugal, 3 from France, 1 from Uruguay, Scotland, Serbia, Tunisia. So this is the bar plot. Now moving on to the next one, histogram. Histogram, it is basically a distribution of your frequency, and the format remains the same, only there is the change in code is of one line. So instead of plt dot bar, which we used in bar plots, we will be using plt dot hist. So very simple, plt dot figure, and here you pass in the fig size, let's say again 15 and 5, and then plt dot hist, and here x will be cdf dot overall. So overall is the for the sake of demonstration, I'll show you what overall is. So every player in this data set is given a rating. So Cristiano Ronaldo, he has overall of 91, Bruno Fernandes 88, Paul Pogba 87, Jadon Sancho 87. So basically, depending on their performance, everyone is given an overall rating. So that is basically overall. So it is a numerical column, so we'll be making use of this mufc df dot overall, and I will not pass in bins right now. So once I show you without bins how the graph appears, then I will show you with bins. So bins are basically the vertical bars which appear in your histogram. Then plt dot title will pass in the string of histogram of overall, then plt dot title, it will be overall, the plt dot. So here the x label, sorry, so the text data which I am passing it over here, that can be anything, that totally depends upon you how you want to name it, and x label, y label, count, and then plt dot show. So if you see, we are getting a histogram of this, and if you see, median is around 80. And now if I give bins, so right now we are getting 1 2 3 4 5 6 7 8 9, only 9 thick bars. So instead of that, if I give number of bins 33, because we have 33 players. So if you see, we are getting total 33 bars, and basically it is giving a detailed frequency, because of more number of bars, vertical bars. So instead of 33, you can change it to 20 as well. So totally depends upon you how much you want to give. I am giving it 33 because total number of rows in this mufcdf data frame is of 33. Now moving on to scatter plot. So scatter plot is basically this particular plot. This is the scatter plot. So we'll be plotting two numerical values against each other. the only change, instead of plt.hist in this second line, you have to use plt.scatter, and x-axis you have to give numeric data, y-axis again numeric data. C is if you have, means you can give the color scheme based upon the color sequentials if you have. So C is basically for color map, and S is for size. That is the size of the dots, the scatter plot dots. So first I will show you without this S value, and then I will show you with the S value. So plt dot figure, sorry, I made a mistake, figure, typo mistake. Then fix size, let's say we want to plot of 10 by 5, and then plt dot scatter, and on x-axis we will have, let's say for example MUFC, which two values we can take. So let us take age on x-axis, and we will take overall on y-axis. So let me minimize this. So on x-axis we will take MUFC dot age on x-axis, and on y-axis it is MUFC dot overall. And if I want to give color map, it will be C equal to the name of this helper function, get color list, and number of colors that we will be needing is length of this MUFC data frame, which is 33. And for right now I will not pass this size parameter. Once I show you how it appears by default, then I will change the size parameter. Then plt dot title, so let us give this title as age versus overall. Then plt dot x label, on x we have age, plt dot y label, on y we have overall, plt dot legend, and plt dot show. Legend will again give warning over here because we have not assigned any particular legend. So this is how it will appear, different color referring to different arrays. So at the bottom we have it in red, at the top we have it in purple. So on x-axis we have this age, and on y-axis we have the overall rating. So the person having the highest age, highest overall rating, 91, Ronaldo, so he is beyond the age of 35. And there is also someone who is beyond 35 and whose overall is around 65. And these are the engaged players whose overall is below 65, the 3 dots in red. And if you see, majority players lie in this 85 to 80 value, and whose age is between 20 and 30. And now if I want to increase, so if I want to play with the size, I will say s equal to, and here I will pass in the integer. So if I pass in as 100, so if you see, after executing this, the size will increase. The size has increased. I'll just comment out the legend to remove this warning sign. So if I make it to 200, it will increase further. If I make it to, let's say, 50, it will decrease. Still smaller. So this is how you can manipulate the size. Sorry, a little too big. Yeah, so now it is appearing properly. So this is how you work with scatter plots. Now moving on to the next one, bar chart on polar axis. So this is a bit difficult one, because here you will be working with a circular circle. So the plot is along the angles. So instead of x-axis, you will be working with different angles. So this part remains the same, plt dot figure. Then the change, where the change comes in is you have to define range of angles. So np dot linspace, and first angles will start from 0 and it will go up to 2 pi. If you only pass in as 1 pi, then the angle will go from 0 to 180 degree. So if you have to pass it as 2 pi, so it goes from 0 to 360. And then how many partitions you want of that particular angles. So we want 33 partitions because we have 33 players in this particular data set, and 33 players as in 33 observations, 33 rows in this particular data set. And endpoint is false because 360 degree itself will be also 0 degree angle. So it will complete an entire circle, and where you complete 360 degree, that will also be the 0 degree. And height, we will be, so height of these bars, we will define it as, so overalls will be displayed as the height, and width of these bars will be edge. So if the edge is quite high, the width will be high. If the edge is low, the width will be low. Same with overall. If overall is high, the height will be high, and if the overall is low, then the height of this bar will be low. So this multiplied by 10 and divided by 300 is basically just to fine tune. It is not required multiply by 10 or divided by 300, but if you don't multiply or divide by these hyperparameters, it will appear a bit blurry. So for fine tuning, I have multiplied it by 10, multiplied the height by 10 and divided by width by 300. So I get a good separate bars along the circle. And color, again I have made use of this helper function, get color list, and we'll be getting 33 different colors based upon the 33 number of rows. And to plot the graph, you write ax equal to plt dot subplot and projection as polar, and then ax dot bar on x axis, which is a circular, you have to pass in the angles, the height as the height and width as the width defined over here. And colors will be as per the color array we have formed over here, and alpha is 0.5. So alpha is basically the transparency of the bars that you will be plotting. So let's write the code plt.figure. So this is general for all. Fixed size, let's say 6 by 6, because circle will appear in a square format, so it will be better if you plot it as with same height and width. Then angle, so it will be np dot linspace, and here we will be taking from 2 into np dot pi, and we'll split it into 33. So 33, because the length of MUFCDF is 33, and then endpoint as false. Then height equal to MUFCDF dot, on height we will be taking overall. Let us convert it to list and multiply it by 10. One more thing, I'll need to convert it to array if I am to multiply it by 10, because on a normal list this will not work, broadcasting operation will not work. The reason why I am converting it to a numpy array is because numpy array you can do the operation of broadcasting. So if I multiply it by 10, all the elements in this array will get multiplied by 10. That's the reason I have converted this to numpy array. Then on width, np dot array, so mufc df dot edge, this will be the width, so edge dot to list, and this I will divided by 300. And colors use is get color list, and number will be 33, which is the number of rows for MUFCDF. And finally axis, so plt dot subplot, and polar projection will be polar. And then x dot bar will be, because we'll be plotting the bar plot, so x equal to angle, y equal to, not y, basically height, we have to define height and width. Height equal to height, width equal to width, and colors equal to colors, and alpha equal to 0.5. so alpha, let's say for demonstration purpose I'll keep it as 0.5, then I will show you with changed alpha, and bottom equal to 0, and let us plot it. So if you see, we have got this graph. So thickness, is related, that is the width of this graph is related to the edge. So if you see, those which are appearing over here have small thickness because their edge is quite small, and height of the bars is directly proportional, that is the height is basically the overall ratings. So if you see this particular bar, the one in purple which is here, so this belongs to Ronaldo's age is, I guess, 37, and that's the reason the thickness of this bar is quite bigger, and also his overall is 91, so that's the reason the length of this particular, that is the height of this particular bar, is also more. And smaller players, their smaller as in the younger players, their age is also small and their overall is also low, so that's the reason their height is small and their width is also small. So now if I change alpha, if I want to darken it, I'll increase the alpha, so let's say 0.8, so it will give a darker version. If I put it as alpha as 1, it will be even more darker. And if I want to reduce the height, I'll remove this and execute. So the height has gotten reduced, and if I want to increase the width, I will not divide it by 300, but then it will not appear properly. So it is appearing quite blurry, so that's the reason I had divided it by 300. So now it will, we have reduced the width, so it is now appearing again properly. So instead of 300, I can do is I can keep it as 100. Now the thickness has reduced, the width has, the thickness has increased, the width has increased, and we have this overlapping bars. And to again reduce the thickness, I am dividing it by a bigger integer, so we have lesser thickness. So that's all for bar chart on polar axis. Moving on to line plot. So basically line plot is drawn where you want to see the performance of basically you want to see performance over an ordinal value. So ordinal is which is in a specific order. So let's say performance of stock market over a given date range, or let's say performance of people based upon the increase in their age, or let's say energy consumption of an individual throughout the day, that is from 12 a.m. midnight to 11:59 p.m. on the next night, that is at the completion of 24 hours. So basically on x-axis we will have this ordinal values, and based upon those values the corresponding values will be plotted on y-axis. So what we will do, we will plot overall of the players against their age, and since this is a line plot, we'll need to sort our dataset as per the age parameters, because if we do not sort it, then we will not get a proper line plot. We will get for demonstration purpose, I'll show you what we will get if we do not sort the values. So plt dot line plt.figure and fix size, let's say 12 and 5, and then plt dot, it is not line, it is just plot, so mufc dot age, it will be on x-axis, and mufc dot overall, it will be on, it is not mufc df, so on y-axis will be plotting the overall. I will not add the other parameters because I just want to show we will not be getting a proper plot if we do not sort the values as per age. So plt dot show, so if you see we are not getting a proper graph. So let us first sort the values as per age. So mufcdf dot sort values, so this will sort the values by age, and this dataset I'll be storing it in line df. So here instead of mufc I'll say line df, instead of mufcdf line df, and now if I execute it will appear properly. So if you see like this, so the younger the player, the lower the overall, and the overall fluctuates between 80 to 85 if we go from 20 to 30, and then again there is a spike beyond 35 going up to 91, which is for Cristiano Ronaldo, which we have in our dataset. And now to add the title, plt dot title line plot for overall versus age, then plt dot x label, on x-axis we have age, and plt dot y label, on y-axis we have overall. And that's all, and then execute it. So we have the title of the graph, then age on x-axis and overall on y-axis. So that's all for line plot, very easy. Then moving on to the next one, pie chart. Now pie chart is basically the name itself makes me very hungry because I love eating pies. So a pie chart, so it is a circle which we are going to cut into small pieces of pie based upon the content of our data. So for this particular example, we'll be forming a data frame where the overall will be only considering those players whose overall is above 80, and we will see to which nationality these players belong to. So if I execute for demonstration purpose, if I show you this pydf, I have converted the data frame to a dictionary format where the keys are England, France, Portugal, that is the name of the countries, and the values are the number of players belonging to that particular country. So the number of players above 80 are these many players, and out of those players 5 belong to England, 3 belong to France, 2 belong to Portugal, 2 belong to Brazil. Now let us plot the pie chart. The format is exactly similar to the ones we have mentioned above. So plt.figure, and here you pass fixed size as, let's say 5 by 5, or let's say 6 by 6, so we get a bigger pie chart. Then plt.pie, and here x, on x-axis you have to plot the numeric column, that is the count of the players. So pydf dot values will come over here, and labels will be pydf dot keys, that is the name of the countries, and auto pct, so we get a percentage annotation in that particular graph. So for that purpose we are using this auto pct dot 2f, so it will be up to 2 decimals, and then plt dot title, so let us say above 80 players, Then because we are seeing the players who are above 80 and the nationalities they belong to, plt dot show, and we will be also be needing legend, so plt dot legend. Okay, so I forgot to mention dot over here, plt dot show. Now it is showing properly, and here if you see legend is appearing on our graph itself. So if you want to change the position, you can do that by passing integer over here. So if you type it as 2, so it should be location, so it is appearing over here. So instead of appearing on England, it is now appearing on the side. So by default location is set to 1, or you can set it to best fit, but if you want to change you can do that, just location 3, location 4. So I guess the best location was on location 2, so you can do that. You can increase the integer and see different locations available in Matplotlib. So this is how you plot a pie chart in Matplotlib. So the next plot that we'll be looking at is stack plot. So stack plot is basically an area plot. For this particular example, I have created this small data frame where I've selected 3 countries: England, Poland, India, and I have created a dictionary where the keys are the name of the countries and the values are 60 players from these countries whose overall are the bottom 30 and the top 30. So in England the values I'll be considering is the bottom 30 players and the top 30 players. Same for Poland and same for India. So if you see over here, England, you have the bottom 30 players and the top 30 players. Same for Poland, bottom 30, top 30, total 60, and India as well, bottom 30 and top 30. So let us plot. The format remains the same, plt dot figure fig size equal to, let's say we plot it on 12 width and 5 height. Then plt dot stack plot. The first thing that will need to pass is, since we have 60 players, the on x-axis the ordinal value should be 60, because the players will be comparing will be from 0 to 60. Then the next parameter I'll need to pass in is the values from this player overall. So from 0 to 60 will be plotting the values of the overalls, that is the top 30 and bottom 30 players. So player overall will be the values of player overall, that is there. If you see over here, player, so this area, this array, so this array will be the second parameter, and labels will be name of the country, so country list, so this will be the labels. And then plt dot title stacked plot of player overalls for England, Poland and India. Then plt dot x label, it will be players, and on plt dot y label it will be countries. And then plt dot legend, just so we know what color is for what country, and plt dot show. And so we have got this stacked plot. So green is for India, then orange is for Poland, and blue is for England. So till here first 30 is the bottom 30 overall, and from 31 onwards we have the top 30 overalls. And if you see narrowness, India's area is narrowness because overall of Indian players is lesser compared to that of Poland, which is in turn lesser than when compared to that of England. So that's how you plot a stacked plot in Matplotlib. Now moving on to the last one, box plot. Box plot is very easy. Basically its purpose is to tell you whether there are any outliers in your numeric data. So we have this mufc df dot overall containing the list of overalls in your dataset. So we'll plot that. So plt dot figure fig size, let's say 10, instead of 10 let us say 7 and 4, and then plt dot box and then x will be, also you can plot other things as well. So you have to pass it in terms of an array. Let's say if you want to also plot age as well, you can do that. So if I want to plot both mufc df dot overall, this will be the first, and then mufc dot age, this will be the second. So I have passed it in terms of array, and right now I will not pass this notch and vert as true. After we plot the graph, I will show you how to put a notch in your box plot. So plt dot title box plot of overall and age, and then plt dot x label, here we will say overall and age, and then plt dot y label, it will be value, plt dot legend will not be required over here, so plt dot show, yeah, so legend was not required over here, so let me just execute it. So this one, the 1 is for overall and 2 is for the age. So here we see there are 2 outliers, and for age we see there is 1 outlier. So this is how you plot a scatter plot. You can also plot a scatter plot only for one value as well. And if you want to increase the size, let's say 8 and 8, and if you want to put a notch, you can type notch equal to true. So if you see, the notch is appearing over here in your box plot. Also you can use this as well. So vert, I forgot what vert is used for, let me just quickly check. So you can check it over here. Yeah, so vert true, if true draws vertical boxes, if false draws horizontal boxes. So we have set vertical as true, by default it remains true, that's why we have received this as horizontal. Let's say if we set vert to false, so we have received the same with horizontal bar plots. So that's the use of vert. Let us keep it vertical for now, and this is how we are getting it. This one is for overalls and this one is for age. It is plotted against the same scale, and that's it for box plot. So in this particular notebook we have seen in total 8 plots: bar plot, histogram, scatter plot, bar chart on polar axis, line plot, pie chart, stacked plot, and box plot. And that's all for this video. This video was regarding plotting graphs using Matplotlib. If you want to message me something, you can message me in the comments, or also if you want to collaborate on something, or if you have any projects, we can work on them. You can send an email to me on shaunak.python@gmail.com, and this link is linked to my YouTube channel where you are watching this video. And this notebook will be hosted on GitHub. The link will be shared in the description of this video. Thank you for staying. If you are with me till here, thank you for watching the entire video. Thank you. The next video will be another I guess the next video I'll be making will be of Seaborn. After that I'll be going to pandas. So stay tuned for the next video. Till then, take care. Bye bye.